In this video, we are going to learn about how to use the specific heat equation. So the one that you're given on the back of your periodic table is E is equal to mc times delta T, which is change in temperature. So what we're going to do first is just identify the different variables that there are, what their symbol is, and what units they're measured in. So energy has the symbol E, and its units are joules. Joules you can abbreviate just as a capital J. Mass is M. Mass we're going to measure in grams, which you can abbreviate as a lowercase g. Change in temperature is this triangle and then T. We call this triangle delta, so this reads as delta T, or change in temperature. Change in temperature will be measured in degrees Celsius, and then specific heat is C, and it's going to be measured in joules divided by grams times degrees Celsius. Specific heat is probably the one variable that you have not heard of before. So the definition of what specific heat is it is the amount of energy that's required to raise the temperature of 1 gram of a substance by 1 degrees Celsius. So each different substance has a different specific heat. So this is an example of the specific heat of copper. And you can see that it's measured in joules divided by grams times degrees Celsius. With specific heat, the smaller that the number is, the less energy you'll need to heat that substance up. So here is a table that shows the specific heat of 7 different substances. So the substance that will take the most energy to heat up will be the one with the largest specific heat value. So that is magnesium. And then the substance that will take the least energy to heat up will have the smallest specific heat value. So that is lead. So let's look at calculations where we need to use this new equation. So we're going to start by identifying all 4 of our variables, E, M, C, and change in temperature. So we're going to read through our problem and pick out the different variables. So we have 225 grams of water. Mass is measured in grams, so M is equal to 225 grams. You're told that the specific heat, that is C, is 4.186 joules divided by grams times degrees Celsius. Change in temperature, we are changing the temperature from 35 degrees Celsius to 5. So to find the change, just subtract the 2. So our temperature changes by 30 degrees Celsius. And then lastly, our energy. So energy is our unknown. We're going to be using this equation at the top to solve for energy. So you simply plug in your numbers that you know and multiply them together. So 225 times 4.186 multiplied by 30. And that gives us a big number, 28,255.5 joules. In the next example that we're going to look at, we're going to be finding or solving for a different variable, but we're going to start out the problem in the same way, just by identifying our 4 variables to figure out which is our unknown. So in the problem, we have 45 grams. Mass is measured in grams. You're told that this substance requires 526 joules of energy, so that's E. And then we're told that the temperature is going to increase by 5 degrees Celsius. So change in temperature is 5. And then in the problem you're asked to find what is the specific heat capacity. So C is our unknown. That means that we're going to use the second equation. This equation is just a rearrangement of this first equation. So C is equal to 526 joules divided by M, 45 grams and then times 5 degrees Celsius. When you divide by these two numbers, put them in parentheses. That will ensure that you get the right answer. So you'll end up getting 2.34, and the units are going to be joules divided by grams times degrees Celsius, because those are the units that you had in your setup of the problem. One last example. This one, again, we're going to start by identifying all 4 of our variables. So energy is 100 joules. You're told that you have a 0.5 gram block of aluminum. So M, mass, is 0.5 grams. C, you're told that the specific heat of aluminum is 897 joules divided by grams times degrees Celsius. And then you're asked to find the final temperature. So the change in temperature is going to be the final temperature. I'm going to abbreviate that as TF minus the initial temperature, which I'll abbreviate as TI. So we are told that the initial temperature is 20 degrees Celsius, but we need to find the final temperature. So we'll have TF minus 20. We're going to use this equation at the bottom to solve for TF. So we're going to have TF minus 20 is equal to E, so 100 joules, divided by M, so 0.5 grams, times C, our specific heat, so 897. So to solve this equation, first plug this part of it into your calculator. Do 100 divided by 0.5 times 897 in the denominator, and then add 20 to both sides of the equation. So whatever number you get in your calculator, add 20. So that will give you TF is equal to 20.22 degrees Celsius.